In this video, I'm going to go over the product rule, the quotient rule, and also the chain rule as it relates to composite functions. So let's start with the basics. Let's go over the product rule. So let's say if we want to find the derivative of two functions that are multiplied to each other. So the derivative of f of x times g of x. This is equal to f prime of x. You take the derivative of the first part multiplied by the g of x. The second part is going to stay the same, plus keep the first part the same, times the derivative of the second part. So that's the main idea behind the product rule. So let's say if we have the function x squared e to the x. So x squared is like the first part of the function and e to the x is the second part. So to find the first derivative, differentiate the first part. So the derivative of x squared is 2x. Then leave the second part the same. That's e to the x. Plus, keep the first part the same, x squared, and then differentiate the second part. The derivative of e to the x is e to the x, so this stays the same. So using a formula, this is like f prime, this is g, this is f, and this is g prime. Let's try another example using the product rule. So let's say if we have the function h of x is equal to x to the fourth times sine x. So we're going to say f of x is equal to x to the fourth power. That means that f prime of x is equal to 4x cubed. Now let's say g of x is the second part. Let's say it's sine of x. Then g prime of x, the derivative of sine, that's going to be cosine x. So using the product rule formula, h prime of x is going to be f prime times g plus f g prime. So f prime, that's 4x cubed. G is sine x. And then it's added to f, which is x to the fourth, times g prime, or cosine. So you can do it that way too. So our final answer is 4x cubed sine x plus x to the fourth cosine x. If you want to, you can factor out the GCF. If you factor out x to the third, you can also write the answer like this. It's going to be 4 sine x plus x cosine x. Here's another one. Let's say h of x is equal to 3x to the fifth power plus 7 multiplied by x cubed minus 5x. So feel free to pause the video as you work through that example. So let's say f of x is equal to 3x to the fifth power plus 7. That means that f prime of x, the derivative, is going to be 15 x to the fourth, and the derivative of a constant is 0, so it's just 15x to the fourth. G of x is going to be equal to the other part of the function, so that's going to be x cubed minus 5x. So g prime of x is going to be 3x squared minus 5. So now we could find h prime of x, which is equal to f of x times, I take that back. It's f prime of x times g of x. Differentiate the first part, keep the second part the same, plus f of x, keep the first part the same, times the derivative of the second. So now we just got to insert it into the formula. So f prime That's 15x to the fourth times g of x, which is x cubed minus 5x, and then plus f of x, which is 3x to the fifth plus 7, times g prime of x, which is 3x squared minus 5. So this is the answer. Now, if you want to, you can distribute, FOIL, and then combine like terms, but I'm going to leave the answer like this. Now, we talked about finding the derivative if we have two parts of a function, f of g. Now, let's say if we have three parts. Let's say if y is equal to f of x times g of x times h of x instead of two parts. How can we use the product rule to find the derivative of this three-part function? So differentiate the first part and then keep the second or the other two the same. And then plus, keep the first part the same. I'm going to have to write it below it. Differentiate the second part and keep the third part the same. And then plus, keep the first two parts the same, and then differentiate the last part. So that's how you can use the product rule if there's three parts to a function, or if you have like three parts multiplied to each other. So here's an example. Let's say if y is equal to x squared plus 3x times 5x cubed plus 8 times 7x minus x squared. So we're going to differentiate the first part and keep the other two the same. So this is going to be, so y prime is going to equal 2x plus 3, that's the derivative of x squared plus 3x. And then we're going to keep the other two parts the same. We're not going to change it. Plus, now we're going to differentiate the second part, leaving the other two parts the same. So the first part, x squared plus 3x, we're not going to change it. Now we are going to find the derivative of the next part. The derivative of 5x cubed is 15x squared. The derivative of a constant is 0. Now the third part, we're going to leave it the same. Plus, now let's differentiate the third part. So the first part is going to stay the same. That's x squared plus 3x. The second part is going to stay the same. 5x cubed plus 8. And we're going to differentiate the third part, which is going to be 7 minus 2x. I highly recommend not foiling and trying to combine like terms. I would leave the answer like this. So this is it. Now let's say if we have a rational function, f of x divided by g of x, and we wish to find the derivative of this function. We need to use something called the quotient rule. And the formula for it, it's g of x, or I'm just going to say g times f prime minus f g prime divided by g squared. So that's the quotient rule formula. Now let's apply it to a problem. So let's say if y is equal to 3x minus 1 divided by 2x plus 1. So therefore we can see that f is the top part of the function is 3x minus 1. F prime is equal to the derivative of 3x minus 1. The derivative of 3x is 3. The derivative of the constant negative 1 is just 0. Now g is the bottom part of the function, 2x plus 1. So g prime is simply 2. So to find the first derivative, we know it's going to be g f prime minus f g prime divided by g squared. So g is equal to 2x plus 1 times, I might need more space here, so let's take this and move it here. So g, as we said, is 2x plus 1. F prime is 3 minus f, which is 3x minus 1, times g prime, which is simply 2. So you have to be careful when you plug this in. If you make one mistake, this whole problem could be gone. So just pay attention to detail as you work out this problem. Now we need to divide by g squared, which is 2x plus 1 squared. So let's go ahead and distribute the terms in the numerator. So let's multiply 3 times 2x and 3 times 1. 3 times 2x is 6x. 3 times 1 is 3. Minus 2 times 3x is 6x, but let's not forget about the negative sign. So it's negative 6x. 2 times negative 1 is negative 2 with the negative sign. So it's going to be plus 2. We can cancel the 6x. So then it's just 3 plus 2, which is 5, divided by 2x plus 1 squared. This is the final answer. So that is the derivative of this function using the quotient rule. Let's try one more example using the quotient rule. So let's say that y is equal to the square root of x divided by x plus 5. So we can see that f is the top part of the function, it's radical x. G is x plus 5. So g prime is just 1. The derivative of x is 1 because we have 1x. And for the constant 5, that turns into 0. But now what is the derivative of the square root of x? So what's f prime? The square root of x can be rewritten as x to the 1/2. The index number of a square root function is 2 if there's no number there. Now we can use the power rule on x to the 1/2. Let's move the 1/2 to the front, and then let's subtract 1/2 by 1. 1/2 minus 1 is the same as 1/2 minus 2 over 2, which is negative 1/2. So right now what we have is x to the negative half divided by 2, since the 2 is on the bottom. Now we can move the x to the bottom. If we do so, the exponent is going to change sign. It's going to change from negative to positive. So this is the same as 1 over 2x to the 1/2. There's an invisible 1 here that you don't see, and now it's visible. Now x to the half, we could change it back to radical x. So f prime is 1 over 2 root x. So now let's use the formula. So y prime is going to be g f prime minus f g prime divided by g squared. So g is x plus 5 times f prime, which is the square root of x, minus f. I take it back. See, I almost made a mistake. F prime is not the square root of x. This is f prime. F prime is 1 divided by 2 root x. And then minus f, which is root x, times g prime, which is simply 1, divided by g squared, which is x plus 5 squared. By the way, you cannot cancel these, since we don't have an x plus 5 on this term. just if in case you were thinking about that. Now, how can we simplify this expression? What can we do? Notice that we have a square root of x on both terms. So what we could do is multiply the top and the bottom by square root x. Whatever you do to the top, you must also do to the bottom. So now let's distribute radical x. So what is the square root of x times all of this stuff? Well, let's write it out. So if we have x plus 5 times 1 over 2 radical x multiplied by radical x, these two will cancel, and it's simply 1/2 times x plus 5. So let's write that. So we have half of x plus 5. Now if we multiply radical x by radical x, that's the square root of x squared. X times x is x squared, and the square root of x squared is simply x. So we could just put minus x. On the bottom, it's just going to be radical x times x plus 5 squared. I wouldn't try to FOIL it on the bottom, at least not at this moment. Now if we distribute the 1/2 to the two terms, what we now have is half of x plus 5 over 2 minus x divided by what's on the bottom. So what is 1/2 x minus 1x? Half minus 1 is the same as 1/2 minus 2 over 2, which is negative 1/2. So what we now have on top is 5 over 2 minus 1 over 2x, which we could take out, we could factor out 1/2. If we take out 1/2, it's simply going to be 5 minus x divided by what's on the bottom. Now this 2, we can move it to the bottom. So we can write our final answer as 5 minus x divided by 2 root x over x plus 5 squared. When we move the 2 on the bottom, we have a 1. Whenever you have a 1 in front of parentheses, you can open the parentheses. You don't need to close anymore. So this is the final answer. Now let's move on into the chain rule. The chain rule allows you to find the derivative of a composite function. Now what exactly is a composite function? A composite function is a function inside of another function. So let's say if g is inside of f, this is a composite function. So far we covered the product rule, which is the derivative of two functions multiplied to each other. That's f of x times g of x. And we covered the quotient rule, which is the derivative when one function is divided by another function. So now we need to use the chain rule when a function is inside of another function. So what is the derivative of f of g of x? According to the chain rule, the derivative of this composite function is the derivative of the outside function. That's the derivative of f. And while you're differentiating the outside part, you need to keep the inside the same. So it's f prime of g of x times the derivative of the inside part of the function. So that's the formula for the chain rule. Now, as we work on problems, keep in mind the process of finding the derivative. The first step is to find the derivative of the outside part of the function. Keep the inside the same, and then multiply it by the derivative of the inside. But before we work on some problems, let's see how we can derive this formula, how we can get this formula, starting with this. So let's say that y is equal to f of u. So y is a function based on the variable u. And let's say u is a function that depends on x. So u is g of x. So if we replace u with g of x, we will get the composite function y is equal to f of g of x. Now, let's say if we start with this function. If we differentiate both sides of this function, what's going to happen? If we differentiate this function with respect to the u variable, we're going to get this expression. dy divided by du is equal to f prime of u. Do you agree? Now, let's say if we differentiate this function, we're going to get du over dx, which is equal to g prime of x. Now, if we want to find the derivative of y with respect to x, here's what we can do. Dy dx is dy over du times du over dx. Do you agree? Notice that we can cancel du. So by multiplying dy over du by du over dx, we're going to get dy over dx. Now we said that dy over du is equal to f prime of u in the last page, and we said that du over dx is equal to g prime of x. Now remember, this originally we said that y was equal to f of u. And we also had y was equal to f of g of x. So just review, we said y was equal to f of u is equal to g of x. So if we insert or replace u with g of x, y is equal to the composite function f of g of x. Just keep that in mind. So the derivative of y is dy dx if we differentiate it with respect to x. So now all we need to do here is replace u with what it's equal to. We said that y is also equal to f of u, and u is equal to g of x. So we could replace this u with g of x. So therefore, we have f prime g of x times g prime of x. That's equal to dy over dx. So therefore, we can make this statement. If y is equal to f of g of x, and if we differentiate both sides with respect to x, this side is going to become dy over dx. Therefore, the derivative of the right side is equal to what we have here, which is f prime of g of x times g prime of x, which is the chain rule function. So now you know how to derive this formula using dy over du and du over dx. So now let's apply this information to a practice problem. So remember, the derivative of the composite function f of g of x is equal to the derivative of the outside part, keep the inside the same, and then multiply it by the derivative of the inside. So let's say if we want to find the derivative of x cubed minus 5x raised to the 4th power. So for the outside part, let's use the power rule. So what we're going to do is we're going to move the 4 to the front. So the derivative is going to be 4. Keep the inside the same. That's the g of x part. That's not going to change. The inside is going to be x cubed minus 5x, so we didn't change it. And then using the power rule on the 4, we need to subtract it by 1. So 4 minus 1 is 3. After that, we're going to find the derivative of the inside. the derivative of x cubed minus 5x is 3x squared minus 5. So that's how you can differentiate this function using the chain rule. Now let's see if we can differentiate it using dy over du and du over dx. So here is the original function. This is the long way, by the way. We need to define what y is and what u is in terms of x. So y is going to be u to the 4th power. U is what's inside of the parentheses. So u is equal to x cubed minus 5x. So u is what's inside, y is u raised to the whatever is on the outside. So let's find dy du. If y is equal to u to the 4th power, then dy with respect to du, or the derivative of y with respect to u, is going to be 4u to the 3rd. Now let's differentiate u with respect to x. So du dx is going to be the derivative of this function, which is 3x squared minus 5. Now to find the derivative of y with respect to x, which is basically this answer, we need to multiply dy over du times d over dx. If we do, the du's cancel and we'll get dy over dx. So dy du is 4u to the 3rd. Du dx is 3x squared minus 5. Now we want the derivative of y with respect to x, so we don't want the u variable, we only want to see x. So since u is equal to x cubed minus 5x, we're going to replace this u with x cubed minus 5x. So it's 4 times x cubed minus 5x raised to the 3rd times 3x squared minus 5. So since the original problem equals y, dy dx is equal to this, which is the derivative of this function with respect to x. So this is the answer. So as you can see, you could do it the short way or the long way. You can get the same answer. Let's try another example. So let's say y is equal to 5x squared minus 7x plus 3 raised to the 3rd power. So what is y prime, or dy dx? What is the derivative of y with respect to the variable x? So using the chain rule, but the easy way, let's differentiate the outside part. So let's move the 3 to the front. Let's keep the inside part the same. So 5x squared minus 7x plus 3. And then subtract this by 1 according to the power rule. So it's now going to be 2. And then multiply it by the derivative of the inside. So the derivative of 5x squared minus 7x plus 3 is going to be 10x minus 7. So that's how you can do it the easy way, using the chain rule. And the chain rule always works. For example, you know the derivative of x to the 4th is 4x cubed. But let's use the chain rule to get the same answer. So let's work with the outside part. The outside part is the 4. Let's use the power rule. So let's move the 4 to the front. Let's keep the inside the same. And let's subtract this exponent by 1. So it's going to be 3. And then what you need to do is take the derivative of the inside. What is the derivative of x? The derivative of x is simply 1. So the whole thing is 4x cubed. So no matter what situation, the chain rule always works. Now let's see if we can get the same answer using the longer method, because sometimes you may have a free response question where you have to do it that way. So it's good to understand it at least. Now for the sake of practice, let's see if we can get the same answer using the other technique. So y is equal to 5x squared minus 7x plus 3. And it's raised to the 3rd power. Now the u variable is equal to what's inside. So u is equal to 5x squared minus 7x plus 3. So therefore, y is equal to u raised to the third. Now our goal is to find the derivative of this expression, which is going to be dy dx. So to find dy dx, we need to find dy du, which is the derivative of u to the third. So that's going to be 3u squared. Now we also need to find du dx, which is the derivative of u with respect to x. The derivative of 5x squared is 10x, and the derivative of negative 7x is negative 7, and this is going to be 0. So dy dx, which is the derivative of y with respect to x, which is what we're looking for, that's the derivative of this entire expression, that's going to be dy over du times du over dx, where du cancel and we're going to get dy over dx. So dy over du, that's 3u squared. And du dx is 10x minus 7. Now, since we want the derivative of y with respect to dx, we don't want to see the u variable. We need to replace it with what it's equal to. U is equal to this expression, so it's going to be 3. Instead of u, it's going to be 5x squared minus 7x plus 3, and then squared, times the derivative of the inside, which is 10x minus 7. So that's how you can get the same answer using the other technique. From here on, we're going to use the easy method to find the derivative of composite functions. So let's say if y is equal to the fourth root of x squared plus 2x minus 9. What is dy dx? Use the chain rule to figure out the answer. The first thing I would do is rewrite the expression. This is equivalent to x squared plus 2x minus 9, but raised to the 1/4 power, since the index number is a 4. Now let's find y prime, which is the same as dy dx. So we're going to take the exponent, move it to the front, so it's 1/4. We're going to keep the inside the same, x squared plus 2x minus 9, and then subtract the exponent by 1. 1/4 minus 1 is the same as 1 over 4 minus 4 over 4, which is negative 3 over 4. Now we need to differentiate or find the derivative of the inside. The derivative of x squared is 2x, the derivative of 2x is 2, and the derivative of negative 9 is 0. So this is our answer. Now we do have a negative exponent, so we can move this term to the bottom. And the 4 is on the bottom, the 1 is on top. So we can write 1 times 2x plus 2, which is simply 2x plus 2. On the bottom we have a 4, and we have x squared plus 2x minus 9 raised to the positive 3/4. The negative exponent becomes positive when you move it to the bottom. Now we could still simplify the expression. We could take out a 2 from the numerator. So it's going to be 2 times x plus 1. On the bottom we have a 4, and we can convert this back to a radical. So this is going to be the 4th root of x squared plus 2x minus 9 raised to the 3rd power. And we could reduce 2 over 4. That's going to change to 1 over 2. So our final answer for this problem is x plus 1 divided by 2, 4th root of x squared plus 2x minus 9 raised to the 3rd power. So this is it. Let's try some more examples. Let's say if y is equal to sine x squared. Use the chain rule to find dy dx. So the outside part of the function is sine, the inside part is x squared. To use the chain rule, differentiate the outside part first. So the derivative of sine is cosine. The inside part is going to stay the same. And then the last thing you need to do is multiply by the derivative of the inside part. the derivative of x squared is 2x. So our final answer is simply 2x cosine x squared. Now, what if you have a question that looks like this? Let's say if y is equal to tangent raised to the third power of 5x squared plus 8. Use the chain rule to find the derivative of that expression. So the first thing I would do is rewrite it. This is equivalent to tangent of 5x squared plus 8, but the entire thing is raised to the third power. So to find y prime, or dy dx, we need to move the 3 to the front. So we have to work with the exponent first. So it's 3. The inside part is going to be the same. That's tangent 5x squared plus 8. And then subtract the exponent by 1. So 3 minus 1 is 2. Now we need to move on towards the inside. So we have to work our way from the outside to the inside. So we're done with the exponents. Now the next function that we need to differentiate is tangent. After tangent, we'll move our way towards the inside and we'll work on 5x squared plus 8. So what is the derivative of tangent? The derivative of tan is secant squared. And then keep the inside the same, 5x squared plus 8. So now we're done with tangent. So let's work our way further towards the inside. The derivative of 5x squared plus 8 is simply 10x. So we can multiply these two. So our final answer is 30x tangent 5x squared plus 8 times secant squared 5x squared plus 8. So that's the final answer for this problem. Let's try a longer problem. Let's say if y is equal to sine raised to the fourth, and then cosine, and then secant x to the third. So first rewrite it. This is the same as sine, cosine, secant x to the third, all raised to the fourth power. So let's start with the exponent. Let's move it to the front. So y prime is going to be equal to 4, and then everything on the inside is going to remain the same. So it's 4 sine cosine secant x cubed, and then 4 minus 1 is 3. So now let's work our way towards the inside. The derivative of sine is cosine. Now inside of sine we have cosine secant x cubed, so that part is going to stay the same. So we're done with sine. Now let's work our way inside of sine to cosine. The derivative of cosine, by the way, all of this is multiplied to each other. The derivative of cosine is negative sine, and the inside part of cosine is the secant. So negative sine secant x cubed. So now let's work our way towards secant. The derivative of secant is secant tan, and the inside part of secant is x cubed. So it's secant x cubed tangent x cubed. Now the last thing we need to do is differentiate the x cubed, which is 3x squared. So this is our answer. To simplify it, you can multiply 4 times 3x squared, which is 12x squared. And then everything else is going to be the same. You can also move the negative to the front. So you could say it's negative 12x squared times all of this stuff. Now let's say if y is equal to 5 plus 4x raised to the fourth power multiplied by 7x minus x squared raised to the fifth power. How can we find the derivative of this expression? So if you notice, we have a product rule combined with a quotient rule. So let's say if f is equal to the 5 plus 4x raised to the 4th power. Let's do it one step at a time. And let's say g is equal to 7x minus x squared raised to the 5th power. To find f prime, we need to use the quotient rule. So we're going to move the 4 to the front. So it's going to be 4, keep the inside the same, 5 plus 4x raised to the 3rd power, and then differentiate the inside. The derivative of 5 is 0, the derivative of 4x is 4. Now to find g prime, we're going to use the same technique. Let's move the 5 to the front. So it's going to be 5, keep the inside the same, which is 7x minus x squared. Then subtract 5 by 1, so it's going to be 4. And then find the derivative on the inside and multiply it to this expression. The derivative of 7x is 7, and for x squared is 2x. So now we have f, g, f prime, and g prime. So to use the product rule, y prime is going to be f prime g. You differentiate the first part and keep the second part the same, plus f g prime. Keep the first part and then differentiate the second part. So let's see if we can make some space. So f prime is this thing right here. We can multiply the 4 and 4. So that's going to be 16. So f prime is 16 times 5 plus 4x raised to the 3rd power. And then we have g. So g is this expression. So let's just rewrite that. So it's times 7x minus x squared raised to the 5th power. And then plus f, which is that term. So I'm going to put it here. So that's 5 plus 4x raised to the 4th power. And then multiplied by g prime, which is this entire expression. So that's times 5 multiplied by 7x minus x squared raised to the 4th power times 7 minus 2x. So that is the answer. But let's see if we could simplify this answer. So how can we simplify it? So what we want to do is we want to factor. Notice that we have some common terms. One common term that we have is the 5 plus 4x. So for the first term we have 3 of them, and for the second we have 4. So we can at least take out 3 from both terms. So let's take out 5 plus 4x raised to the 3rd power. Now, we can also factor out 7x minus x squared. Here we have 5, and here we have 4. So we could take out 4 from each term. So 7x minus x squared raised to the 4th power. So now what's left over on the inside? Let's move this to the left. So looking at the first term, which is basically all of this right here, we took out all 3 of the 5 plus 4x, so that disappears. We still have the 16 left over, and we took out 4 of the 7x minus x squared, so we have 1 left over. So we have 16 times 1 7x minus x squared. That's what we have left over. Now for the second term, which represents all of this, we took out all of the 7x minus x squared. We took all 4 of them out. So we don't have no more of that term. Now we still have a 5 left over, and we have the 7 minus 2x. And we took out 3 of the 5 plus 4x, so there's only one left over of that. So this is going to be plus 5 times 7 minus 2x times one of these. So just a single 5 plus 4x. So now let's focus on this part of the expression. Let's simplify it. So let's distribute the 16 to 7x and x squared. So 16 times 7x, that's 112x, and 16 times negative x squared is negative 16x squared. Now let's distribute the 5 to the 7 minus 2x. So that's going to be 35, and 5 times negative 2x, that's negative 10x. And we need to multiply 35 minus 10x with 5 plus 4x. So let's FOIL. 35 times 5, that's 175. 35 times 4x, that's going to be 140x. And 5 times negative 10x, that's negative 50x. And finally, negative 10x times 4x is negative 40x squared. So let's combine like terms. So negative 16x squared and negative 40x squared combined, that's negative 56x squared. And then we have 140x minus 50x, which is 90x. And we need to add 112x to that. So it's going to be positive 202x, and then plus the 175. So now we can write the final answer. So the final answer is going to be 5 plus 4x raised to the third power times 7x minus x squared raised to the fourth power times this stuff, negative 56x squared plus 202x plus 175. So that's how you can solve a problem that contains a product rule and the chain rule. Consider the data table that we have on the upper left side. Now let's say h of x is the product of f of x and g of x. Using the table, calculate h prime of 2. So how would you do it? Well, first you want to find out what h prime of x is. You want to write an equation for it. H prime of x is equal to the derivative of f times g, which is basically the product rule, which is f prime g plus f g prime. So therefore, h prime of 2 is equal to f prime of 2 times g of 2 plus f of 2 times g prime of 2. So let's calculate it using the table. So what is f prime of 2? So when x is 2, we're looking for f prime, which correlates to 7. So f prime of 2 is 7. Now what about g of 2? So here x is 2 in this column, and here's g of x. So these two, they intersect at 4. So g of 2 is 4. Now what is f of 2? So here's x equals 2, here's f. They meet at 0. So f of 2 is 0. And then g prime of 2. So g prime and 2 meet at 1. So g prime of 2 is 1. 7 times 4 is 28. 0 times 1 is 0. So h prime of 2, according to the table, is equal to 28. Now let's say if h of x is f of x divided by g of x. What is h prime of 1? So this is the quotient rule, and the formula for the quotient rule is gf prime minus fg prime over g squared. So it's going to be g of 1 times f prime of 1 minus f of 1 times g prime of 1 divided by g of 1 squared. So what is g of 1? So x is 1 over here, and here's g. So they meet at 2. So g of 1 is 2. Now what about f prime of 1? What is that equal to? So we're at 1 again, and we're looking for f prime. So they meet at -3. So f prime of 1 is 3. And then f of 1 is 5. And what's g prime of 1? So g prime of 1 is -8. Now what about g of 1? So we said that g of 1 is 2. So on the bottom we're going to have 2 squared. So 2 times 3 is 6. -5 times -8, that's +40. 2 squared is 4. So our answer is 46 divided by 4, which if we divide the top and bottom by 2, this reduces to 23 over 2. Now what is 23 over 2 as a decimal? (23 over 2 is the same as 22 over 2 plus 1 over 2. 22 divided by 2 is 11. 1/2 is 0.5. So it's 11.5. Now let's try a composite function. So let's say if you want to find h of, let's say h of x first is f of g of x. And you want to find h of, let's say 1. How would you do so? So we don't have any derivatives for this problem. So h of 1 is the same as f of g of 1. So the first thing we need to do is work on the inside. We need to know what is g of 1. Now based on the table, g of 1 is equivalent to 2. So let's replace g of 1 with 2. So now we got to find out what f of 2 is equal to. So when x is 2, what is f? Notice that it's equal to 0. So h of 1 is equivalent to 0. Now let's say if h of x is still the composite function f of g of x. What is h prime of 0? Feel free to pause the video and work on that example. So the derivative of f of g of x is going to be f prime g of x, or g of 0, since x is 0, and then times the derivative of g prime of x, or g prime of 0. So first, let's calculate g of 0. So when x is 0, what is g? G is 1. So we have a 1 on the inside. So this is equal to f prime of 1. So we replace g of 0 with 1. Now, what is g prime of 0? So at an x value of 0, g prime is 6. So this is times positive 6. Now, what is f prime of 1? So when x is 1, what is the value of f prime? Notice that it's negative 3. So what we now have is negative 3 times 6, which is negative 18. So h prime of 0 is equal to negative 18. So that's how you can evaluate the derivative of a composite function using a data table. Try this example. Let's say h of x is equal to g of f of x. This time f is inside of g. Calculate the value of h prime of 2. So the derivative of g of f of x is going to be g prime f of x, or f of 2, times the derivative of the inside, which is f prime of 2. Okay, so let's find out what the value of f of 2 is. So when x is 2, f of x has a value of 0. So f of 2 is 0. So now we can evaluate g prime of 0. So g prime of 0, when x is 0, g prime is 6. So we have a 6 on the outside. And now we got to find out the value of f prime of 2. So when x is 2, f prime is 7. So f prime of 2 is 7. So therefore, h prime of 2 is equal to 6 times 7. And 6 times 7 is 42. So 42 is the final answer for this problem. Now let's say if h of x is equal to f of x. What is the value of h prime of 2? Go ahead and try that one. So first, we need to know what the derivative of f of x. So it's the derivative of the outside part, f prime, and we need to keep the inside the same, but instead of writing f of x, we're going to write f of 2, and then times the derivative of the inside part, so f prime of 2. So now we can use the table. So let's start with f of 2. When x is 2, f of x is 0. So f of 2 is 0. So we could put a 0 here. Now what is f prime of 2? So when x is 2, f prime of x is 7. So f prime of 2 is 7. So now we got to find out what f prime of 0 is equivalent to. So when x is 0, f prime of x is 5. So we can replace this with 5. So it's 5 times 7. Therefore, h prime of 2 is equivalent to 35. So that's the answer for this one. So this is going to be the final example for today. So let's say h of x is equal to g of x. Calculate h prime of 1. So what is the derivative of g of x? It's going to be g prime, the derivative of the outside part. We're going to keep the inside the same, but instead of x, we're going to write 1, so g of 1, times the derivative of the inside part, so g prime of 1. So let's find out what the value of g of 1 is. So when x is 1, g of x is equivalent to 2. So g of 1 is 2. Now, what is g prime of 2? What is that equivalent to? So g prime of 2, when x is 2, g prime is equivalent to 1. So let's put a 1 here. Now, what's g prime of 1? So when x is 1, the g prime is negative 8. So this is 1 times negative 8, therefore h prime of 1 is equivalent to negative 8. So now you know how to answer these types of problems. So that is it for this video. Thanks for watching and have a great day.